Hello, everyone. Today is June 29th, 2022. This is the Kubernetes Data Protection Working Group meeting. Today, we have Yvonne who will be going over the CBT cap. He will be talking about aggregated API server. So I'll just hand it over to you, Yvonne. You want to share? Let me stop sharing.
Yeah, thanks, Xing. Yeah, let me switch over to my screen. Can you also see my web browser?
Yes.
Okay. Yeah, just a very quick recap for those of us who may have missed like the last couple meetings. So we have been working on like the change block tracking cap for the past couple of weeks. Last week, we got some feedback from the production readiness review group, basically asking us about like our proposed design with the two hop type of requests mechanism. So a few of us have reached out to me after the meeting to ask for more clarification around the feedback and options to consider. So just want to clarify that like the production readiness review group did not, outright reject our proposal. They're just saying that, you should consider, like something like an aggregated API server. Ultimately, the approval decision rests on the SIG storage, whether to go ahead with this or not, especially since this is an out of tree like implementation. I think like the implication there is more like like within Kubernetes, like so far there haven't been any like this type of two hop requests type of mechanism. So it's just more like a, hey, if we go ahead with this, we might end up with more questions down the road in terms of supporting it, in terms of maintaining it, etc. So being good like CAP citizen, like we just decided to take a step back and reevaluate the very, very early proposal on using an aggregated API server. And since like I think late last week, I had a chance to speak with Stefan Szymanski. Like some of you might know him from Red Hat. He is he has been very active with the Kubernetes API server. He has been very active with the API machinery group. I think he's now part of the KCP group as well. So basically share like the problems that we are trying to solve with him, especially in light of how aggregated API server can help us out here. I think like, and then like just like documented some of the key point that we talk about inside under the alternative section inside the cap. I didn't, as I mentioned to Xing earlier, I didn't write like the sub proposal inside this cap. I didn't write the sub cap inside this main cap. The idea, I guess the general feedback from Stefan is that like we don't. Yes, we can use aggregated API server, but to accomplish what we want to accomplish, we don't need an aggregated API server. So the feedback there is not like, no, that is evil. Don't even try it. But it's like you can do it, but not sure if it's going to help you to do what you want to do. And as a refresher,
can you explain what an aggregated API server would give us that the earlier proposal of the two hop API doesn't? Because my understanding is if you did an aggregated API, it would still end up looking like a two hop API call.
Yeah, Ben, that's exactly it. That's the main thing that comes out of the conversation with Stefan. Because like the moment like we start using aggregated API server, yes, we can like modify the storage and say, hey, don't put anything into etcd. But like now we like the request and the response path will go through the Kubernetes API server, and the only way to like not like bog down like the Kubernetes API server is to, again, like using that mechanism that we have proposed, is to provide some sort of quote like an out of band like callback URL right? There's and with that, like the main thing there is like we don't need an aggregated API server to do that because we already.
Can you slow down this side also? Since I have not really looked at how aggregated API server work. Maybe you can. This infrastructure needed section, is that part of this alternative? That's something different.
Yeah, so basically, it's like it really boils down to like it's like an implementation details. So in a very high level,
there are a diagram, okay, or if not, you can just talk through this.
Not a diagram with aggregated API server. I think in general, like for those of us who are not familiar with it, it's just like like you still create a custom resource, but you don't need to define like a CRD. You like with aggregated API server, you do your own like wiring. You say like this is the Go GVK and GVR, and then you bind it to like an endpoint. You do basically all that yourself.
Hold on. But you would still need to submit a request, right? So let's say, okay, can you just maybe work through the steps? Because otherwise I'm not getting it. So I don't know if you have more details under the infrastructure needed section. So let's say if you just go through this CPT, for example, let's say I want to do right now we have the CRD, right? What is that called? Delta volume snapshot.
Volume snapshot delta.
So do we use the same CRD or is that different? Because that's the first question. So if you just go can you walk through that example?
Yeah, so from a user perspective, like a user again can be a human or like another software process. It will create like a volume snapshot delta custom resource. But with an aggregated API server, you don't need to deploy the custom resource definition.
Okay.
Because like inside the API server, aggregated API server code, we have to do all the wiring ourselves. We define the storage, we define the REST endpoint, we map it together. Like there's a lot of low-level code.
Okay. So it's basically you probably want to deploy it in some like this other at a different place. You will have to
and this is with an aggregated API server, like it's like we can't like Stefan highly recommend that we don't run it as a sidecar. Like it's he said one of the limitation of aggregated API server is not scalable, in a sense like if we look at matrix server, like there's only one instance of it. You can scale vertically, but you can't scale horizontally. So anyway, so like so I guess like so Xing to I guess like it's like
so the original reasoning behind proposing the aggregated API server was when we started looking at the amount of CBT data and storing it all in the API server in etcd. It was like, oh, that's probably too much, more than we want to store. So the idea behind proposing the aggregated API server was it doesn't need to store things in etcd. All the rest is kind of, side effects, right? But rather it would pull it on demand from the gRPC CSI calls.
Yeah.
So that was the reason why it was proposed. All the rest is like, things that actually happen.
Yeah, and we can do that without an aggregated API server. We can bypass SCD. So like I guess going back to Ben's earlier point, like with the proposal that we have, given like we can like stream or send the response, the payload directly back to the user via like a separate like direct endpoint, and whether it is aggregated API server or just a plain old HTTP server, we can do that. And the point around like, so I think some of us brought up like delegated authentication and authorization to the API server. Again, like that problem has been solved. Like Prasad and Abhishek work on a prototype for the past couple of weeks on it. Like it's basically just boils down to like some token review API, like subject access review API that you just send like the token or whatever, like to API server and said, can I trust this request or can I trust this caller?
So Ivan, can you for now, can you don't go back to the existing proposal? Can you just focus on this alternative? Just make sure like we all understand how this actually works, because I see Michelle is on the call now. Last time I think she asked you to write up like how, how this works, right? So maybe can you just go step by step? Okay, so you said, so the CRD probably will be the same, but the CRD probably will have a status which with all the data. Will that be different? The CRD will be different from what we have in the main
So-
proposal, right?
Right. So okay. Yes, I can go through the step by step, but one thing I want to make sure we decouple from each other is like the API, the CR, CRD, whatever we want to call it, is separated from the aggregated API server.
Okay.
Like the API doesn't change with API server, aggregated API server or HTTP server or whatever we want to call it.
Mhm.
So aggregated API server is an implementation details, and it's just the transport mechanism.
But I thought the CRD, the part will be changing is that you wouldn't have that URL thing, right? Because that was specific for our main proposal. So the CRD will look different, correct?
No, okay, so that was the proposal, but with the aggregated API server, remember, like if we don't have a callback URL, everything still have to go through the Kubernetes API server.
But then, no.
And or like it basically just goes back down to so okay, which
so,
one do we want to tackle first?
Maybe did you write down how the CRD would look like?
It would be the same as like so
It would look exactly the same as what we have.
No, I thought the big difference was going to be, so I don't know where you wound up with the URL or the HTTP thing, but with the aggregated API server, the CBT records would appear to be records in the API server. They're just not. They're
In the
served by
status,
the
I
API
thought,
server.
right? Somehow in the status.
I think they needed to be independent because you want to be able to pull them out one by one using the regular Kubernetes mechanism. So that was kind of the goal of the aggregated API server,
but
was
then-
it looked like they were individual records.
Yeah, but when you okay, maybe we're okay. So
you see, you see that approach doesn't work, right?
Oh, that's okay.
Like-
That's we're trying to understand what it does or what it,
Yeah,
how
Can
it
you
works,
just
right?
talk about
so Xing's asking about the
how-
difference in what the
how that would
what it
work?
would
Can
look
you
like
just-
in the API server.
Maybe you can just walk us through like the example without going back to the main proposal, just to say, hey, how this would work with
Okay.
the aggregated API server.
Okay. Let's see. What is the okay, so how it will work. Okay. So with an aggregated API server, I don't have any YAML example here. So from the user perspective, like they can still create a custom resource that do this. Hey, give me, the base volume snapshot target. And then the aggregate, they just create it in the form of YAML. And then the aggregated API server, it would watch and respond to it. Well, more like the Kubernetes API server would delegate the request to our aggregated API server. The aggregated API server would run as a separate service. It cannot run as a sidecar. It has to run as an independent service inside the cluster. So now, like the core, the logic just become like a reconciliation controller, right?
Wait. I thought the aggregated API server was just there to serve CBT records.
So let me finish. So yes, basically it will do what we have been talking about. So the aggregated API server,
So you should write a request for the CBT data, and then you get back a status that says, yes, this is ready. But then rather than it all being in the status, it looks like it's a set of records in the API server, right? I thought that's
how does the aggregated API server, it will make a gRPC call.
Yeah, but
right?
in terms of what it looks like from the Kubernetes user point of view, right? It should look like there's a bunch of CBT records, like one for each segment.
So the CBT record, I want to make sure we're on the same page. The CBT record comes back from the backend, right? The storage provider.
No. Stop. Don't worry about the backend. So I think first question is, what's the front end? What does it look like from the Kubernetes user point? And then we can talk about how it actually gets served. But
okay, so sure, let's
the regular
backtrack.
stuff. So when you created the request, that should go through the regular controller mechanism. That doesn't hit the aggregated API server, right?
Sorry, where is the control mechanism if it doesn't hit the aggregated API server?
So if you say, for example, I want a, you put in a request, what is it called? So you put in a
Snapshot delta. Yep.
yeah. So you put in one of those, right? That doesn't go through the aggregated API server.
Where does that go then?
That was just a regular Kubernetes record stored in the API server that goes to the controller.
What do you mean the regular? Okay, so when you have aggregated API server, do you still have the normal API server? I guess that's my question. I guess I don't know how this thing works at all. So
yeah, so you have we will okay. So if we have an aggregated API server, we don't have a separate CRD controller.
We don't have the we
don't. That's so. I think the original thought was that everything works the way it works except for the CBT records themselves. That was my thinking. So you write your volume snapshot delta, was it a request? That all goes through the normal mechanisms. It goes into the API server, it goes into etcd, the controller gets triggered, it updates the spec and all the rest of that. So that all works the way it normally works. It's when it's the CBT records themselves that you could serve back through the aggregated API server because you don't want to store those in etcd. That was the proposal. That's what I thought we were proposing. That's what I thought it would. That's the way I thought it would work.
So I guess so that goes back to early. So okay, so if we so following that pattern, following that thought, so something okay, so there is a separate route for the CBT requests. So it was
the records.
CBT record. So it will still be a 2-hop thing, right?
Yes, it would. But that was the only thing that was that we had a performance issue with, or
right. So now that yeah, exactly. So now we go back to Ben's very early point. Why does we need an aggregated API server for the second hop?
Well, we don't need it. It was a proposal, right? So the idea behind proposing that was, hey, we'd like to be able to read the records using the existing Kubernetes mechanisms, so that things like pagination just get handled by the standard Kubernetes pagination. You ask for n records at a time, rather than having to chunk them, right? Because we had one proposal that it was going to be chunked into different pieces that you would ask for, and then you'd have to ask for the next one. And there's kind of a whole lot of back and forth state that wound up being exposed into the API. So rather, it would appear as though all the records existed, or you could query, you could list, you could retrieve records individually. And those records, as CBT records, would, from the Kubernetes user point of view, look like you had 1,000 CBT records for each individual segment sitting in the API server, but they're actually handled by the aggregated API server instead, so they don't have to live in etcd. That I thought was the idea behind it. Does that make sense?
So
sounds like we have not understood how does the aggregated API server mean. I mean, because it sounds like Dave was saying that you can actually have a normal API server and aggregated, like two things, but then saying you cannot.
You see, that is the thing that I feel like that's the thing that we have a bit of disconnect. Right now, I'm saying we do not need a controller and an aggregated API server.
Okay, so let's say if we go with the
because an aggregated API server, it basically is a lower level form of custom resource handling.
Okay.
And to Ben's earlier point, if we still want to do these 2-hop things, pagination or whatnot, we do not need an aggregated API server.
I'm not. The point is not whether we need it or not, but there is a comment there, right, saying why do we use this. So I just want to figure out how that actually works. I don't think I have completely got the answer. Then we got distracted to different directions. So,
but there's one more thing about the aggregated API server. It sounded like there's 2 ways to do it, and one of them would actually involve 3 hops, not 2, right? If you have to go from the client to the Kubernetes API server, and then from the Kubernetes API server to to our server, and then from our server to the actual CSI implementation. Like that, there's 3 hops in that mode. Of
Ben, when you're
aggregated
saying
API.
Ben, when you're saying our server, are you referring to this aggregated API server? What is our server?
The piece of code that would be written for this.
Well, I don't think we ever thought that there was a performance issue in retrieving the CBT records.
It is
Right.
like
No,
holding
yeah,
it,
so-
like we don't want to hold all of those in the API server. That
Right,
won't-
we have to be able to stream them, which means they can't. There's no storage in the middle. You just have to be able to stream the response across. But anyone who objects to 2 hops would probably object more to 3 hops, just from a design perspective.
Okay,
I
so
personally
Ben,
think
when
2
you
hops
think
is
about
fine.
3 hops, can you? Okay,
No, Ben,
I guess
Ben's
that's
right,
do not
because
know
the,
this.
because the
are you
Kubernetes
talking-
API server acts as a proxy.
Sorry, let's I guess like is aggregated API server okay? So Xing, I know like your earlier question is still like how you want to get to know how it works, like in the context of this cap.
Right.
I think that's a very fair question, fair thing to do. So okay, let's try that first. Okay, can I just quickly walk us through, like without like so like just a normal aggregated API server without that extra hops can and then we can just decide and part of it is I feel like unless there's a hard requirement on aggregated API server, like okay, let's try that. So I think like okay, so with an aggregated API server, we will deploy it as an independent service, like a deployment workload. It cannot run as a sidecar because like it doesn't scale. You look at metric server, like there's only one instance of it. You cannot have multiple replicas of metric servers. So from a user perspective, yeah, they would create the requests, right? So it would be the YAML with the base target volume snapshot names at the minimum, and then the aggregated API server, which in itself is a controller. It watches for like creation events of volume snapshot delta. It pick up the request, and then like now it makes that second gRPC call to the CSI driver. So and then of course like there has to be some discovery mechanism.
Question: if it's not deployed the sidecar, how does it call the CSI driver directly?
It needs some way to discover it. So whether as a config map or inside the CSI driver object, there has to be like a URL that says, if you see a volume snapshot delta with this CSI driver name, you call this CBT endpoint. It needs some sort of discovery mechanism.
But it cannot call gRPC directly. I guess that's what's my.
Yeah, there would be the hence like there would be some like there's like now we're gonna go into the rabbit hole of now we need to like do code generation on both the aggregated API server side and on the on the CSI driver side. But we cannot run
the question of how you scale the CS, because this is fundamentally like the question is how do you scale the CSI driver itself, right? If you're concerned that one sidecar on one node can't process all these requests, like you need a way to scale that horizontally.
This is not even a sidecar.
Well, I mean, no, it could be a sidecar, but we're saying that
it's not a sidecar, right? He was saying it's not a sidecar.
The argument against the sidecars is a scaling one, right?
Scaling one, and like we the reconciliation, like like we need to make sure that there's only one API server is doing the reconciliation.
Okay, I mean, you already have this problem with CSI drivers in general, right? That there's a singleton running. I mean, you can have multiple running with leader election, but only one of them is active at a time, and the active one processes all of the requests. And if it bogs down, then the system bogs down, and that's a general problem for CSI drivers. And so this doesn't seem like a new problem with regard to CBT tracking. It's just another entry point that is going to add more load to the system. If you want to scale this entry point, you basically come back to like you got to find a way to run multiple copies of at least the CBT portion of the CSI driver on different nodes to get scaling. And once you do that, you may as well ask the whole CSI driver to scale across nodes, because this is, I mean, it's not a fundamentally different problem than the rest of what a CSI driver does. So
Yeah.
I would separate the does it scale question, and maybe say for the first version, like assume that one sidecar on one node is enough and see if we can make that work, and then tackle the scaling question as a more generalized, can you make the CSI driver scale? Because I mean, CBT only matters if you're generating lots of snapshots, and snapshots mean something has to be creating those snapshots, and that if that part can't scale, you have to scale that too. There's lots of scaling problems in CSI that haven't been tackled.
Oh, maybe let's just put this question
Right.
on hold, the scalability question, right? So can you, okay, maybe you can continue. So we
Yeah.
okay, so let's say, assume we have this one. Let's assume we don't worry about scaling.
Okay, so assume like somehow
Then
like
next.
the aggregated API server, is able to find like the driver plugin whatsoever, make the gRPC CSI gRPC call, and then like I think we're familiar with that part of that segment of the request, right? So gRPC response come back to aggregated API server. So now the challenge is, how does the aggregated API server send those response payload back to the user? It cannot put it into the status sub resource, because you put it into the status sub resource, the only way the user can see it is that you persist those data into SCD, because it's declarative, right? Like it's not like a HTTP request response call.
Whoa, wait, but the idea was that the aggregated API server allows you to serve CBT records.
Yeah, so I'm just trying to like sorry,
So
like,
aggregated API server versus the CBT server, right? Because putting things, so I think the question is, what's the API for getting CBT data back? So one option was put it all into etcd and try to retrieve it that way. Didn't think that would work well. We didn't like that one. The aggregated API server idea was that you could access it via the Kubernetes mechanisms, but not stored in etcd. And when you tried to read a CBT record, that should go through the aggregated API server, which would then do the gRPC call. So maybe some performance implications there, but you don't have this large amount of data sitting in etcd. The URL was, you'd return a URL that you could then make REST calls to retrieve CBT records, right?
Yeah. So before we go down there, so far, like, Xing, is it clear like about like how things are flowing?
I don't think it's clear.
Okay.
I think what Dave said seems to be what I was thinking. But you were talking about only there's one server, so there's not another API server.
Okay, so
everything processed together in one server and on one controller. I'm not getting why this is.
So I'm not talking about one controller and one server right now.
But
are we still talking about that?
But you started that way, right? So I have not seen you going to another place.
I said it's only, I said like with the
there's one aggregate. Okay, so there's one aggregated API server. That's a central controller, right? So we talked about that one.
Mm-hmm.
Somehow we need to be able to make calls to a CSI driver. So we forget about how to do that, but I just assume that can be done. Then okay, and then what? How are we going to get the status back? Okay, going back to Dave's question, I'm not picturing how this would work. It's just everything processed in this one controller, and then what? Guess I'm not seeing how this aggregated API server is different from regular.
Yes, I think that's the key point, right?
Right.
Aggregated API server is not different.
But if it's not different, then why there's this concept? I'm not getting what is that? Why do we do that? I don't see any difference now, other than it's just like a controller. One controller, there's no sidecar, but that's not a point. What we want, the problem we want to solve is how do we have those, the data back, right? Getting those change blocks back without storing that in the main API server. But I'm not getting that question answered. So
I think
Michelle, do you have any problem with your mic? I can't. Are you talking?
Hello, can you hear me?
Oh. Yeah, I can hear you. Yeah. Michelle.
Okay, so I think the main benefit of the aggregated API server is that you can have sub-resource. If you remember Kubernetes API, you can have, I don't know, pod has sub-resource with logs, and you can stream the logs from kubelet through the API server. to the client. And the logs can be megabytes and gigabytes, and nobody cares. This is not stored in the etcd. And similarly, you can have a sub-resource with CBT. You can stream CBT data from the CSI driver to the client without storing them anywhere.
Is
Using
it
a
similar to
sub-resource.
the main proposal though, Jan?
No, it's something completely different. Like you can still have you will still have the delta object with spec and status. And the delta object will also have a sub-resource with custom protocol. I don't know, it can be like simple JSON or anything, where you can stream the CBT data from the driver.
And it would flow through Kube API server, right? It would just proxy that data.
Yes, it would be just proxy.
Yeah.
So you can do that with the aggregated API server.
Okay.
The benefit is it looks like a sub-resource, and it
require
piggybacks on all the RBAC
right?
and everything, right?
Yes,
So
you can have
does that require
Jan,
does that require sub-resource? Because we don't have a sub-resource for our CBT.
Yes, it requires sub-resource.
Okay, yeah.
Like logs or kube control exec also uses a sub-resource to.
Okay, so that's like we need to add this
terminal.
We need to add that in a core API basically. If you propose a core.
No, it's done by the aggregating the API server.
I know, but that's something that needs to be approved. That's not something that not like auto-tree. I'm just saying that's not an auto-tree thing. That will be tough to get that one. I believe we actually looked into that one before. So for something else, I forgot what that was. Yeah, we actually looked at that before, the sub-resource thing. Michelle she actually reviewed something. Yeah. But I think we will try not to. That's like proposing something in core. Okay.
It's not in core. It can still be like in the external snapshotter.
It can. Okay.
Yeah, it can, or wherever this aggregated API.
Yeah, but basically they need to accept it, right? So we need to.
Can CRDs have sub resources? I thought that was.
Which one? Sorry.
A CRD cannot have a sub resource. Isn't that correct?
It can have only status and scaling.
We can have status. Status is a sub resource.
Right. But it can't have the kind of sub resource that we're discussing here.
No. That's why you have aggregated API servers.
That's what I'm saying. So Jan was saying that it's possible to kind of
because that makes it not a CRD. That makes it okay. I see the critical difference.
So Jan, with a sub-resource approach, I think the key is like everything still have to go through the Kubernetes API server. So
even just as a proxy. So like if you do kubectl logs, it also goes through the API server, and nobody complains about gigabytes of logs.
Okay, so Dave, I don't know if you see the chat from Michelle. I think Michelle has problems with the mic. Michelle, you want to try rejoin? So good if you can talk. I don't know what's going on. Let's see, Michelle.
Yes, I'll work with Ivan. I mean, we had I thought.
So hey,
maybe I understand.
Michelle is asking if you could help draft a quick high-level user workflow. He said looks like you understands it.
We'll do it. At least that was a proposal. I'm not sure I understand aggregated API servers completely, but that was the proposal. But anyway, I mean,
But Michelle, you want to see how does a high-level user workflow work with aggregated API server? Is that your question? Because if we only looking, okay, yeah. So I think Michelle still want to have this. I think that would be helpful for me as well. I'm still getting mixed answers.
I think it's worthwhile to at least look at the different options and then say, this is why we didn't take it. And here are the pros and here are the cons, and the cons outweighed the pros. So the problem we had was, how do we get the CBT data back in a way that doesn't blow up etcd? Because it's not just the single spec or the single Delta request. You might have hundreds or thousands of them. If somebody doesn't put them away, you wind up with a large amount of data. So every proposal right now is going, there's the initial proposal that you keep it in the API server. Every other proposal goes around etcd somehow. And so it's a matter of choosing which of those other proposals is the way to go, I think, right?
So Dave, it sounds like the aggregated API service it would be kind of similar to the main proposal, where you could have like 2 hops, but it's just going through this aggregated API server way, maybe more.
Right, and just not storing it in etcd. That was the thought, and I don't know if it actually works, but that was the thought. So
I thought okay, so that's slightly different from my understanding of what Jan was talking about. We don't need a two hop with the aggregate API server because we proxy it through Kubernetes API server.
That's still the extra hop. I mean, there's basically two. So I think there's two ways to use the aggregated API server. So one would be to essentially return a stream like the logs do as the sub resource. And the other, I believe you could simply provide a set of records through the aggregated API.
So okay.
So those are two options. So the sub resource I wasn't really aware of. So we can look at those two, but I think we should just get the pros of it out and then the cons of it out, and then be able to say this is why we did or didn't do this.
Okay. So yep, that sounds like a reasonable next step to research. I wanna talk about unless there's something like we really want to dive into with aggregated API server right now. Can I share like a different approach without like the two hops and without aggregated API server?
Yeah, go ahead.
Okay. So what if like instead of like providing either a callback URL or tell the caller to call a sub-resource endpoint, can we like inside the spec ask the user provide us with a URL to send the data back to? So, essentially, so I've been thinking about this So potentially what we do is like, if you guys can see my slide, inside the spec, we define something called a client config. So what that looks like is if some of us have seen like the emission webhooks resource before, it's really like you tell the service what to call to complete the request basically. So in this case would be like the backup server create this volume snapshot delta. It provides us either with an in-cluster service name or an external URL, either one, not both. And then provide us with like a CA bundle that we can trust the endpoint with. And then our controller still function as a sidecar. We get back the gRPC, we make the gRPC call, get back the workload, and then we send the workload to the endpoint or the service provided by the backup server.
Well, would that send all of the CBT records then, just as a big bundle?
Yeah, so that would be the pagination would have to happen inside the either the CSI driver. So the user
client, I just get back a stream of stuff of everything, right?
You get back like a stream of like paginated like responses. So like
but I get all of the records as a stream. I don't really. There's not an option here for started this offset, ended that offset.
We can we can update the not in mid-flight, not in mid-flight. So it has some like the spec can contain like some offset and pagination parameters. So that would be the starting point. And then after that, it would just be like the kubectl or Kubernetes list command, and they like the backend would send you back like chunks of responses or paginated responses, but over like a one single stream. So now we are back to like, hey, we have one controller and just RBAC of the resource, no only RBAC for the endpoint. We don't need to deal with sub resources. We don't need to deal with
I missed this green. Those are the green thing. Those are filled by who? By backup software or?
Yeah, by the user. So this
backup
is like
software when this is like when user. Who is the user? It should be backup software, right? You want to backup software will be the one who typically create this to retrieve the data, correct?
Yeah. And then the backup software would tell us where to send the responses to.
But the driver would be the driver is the CSI driver's name. What is the sample CSI? That's a CSI driver that you are going to retrieve this. Okay.
Correct.
Oh, that's just the driver name, basically the CSS. That's the driver name. Okay.
Yeah. So now, like, we have one sidecar model.
But then the URL is also
model.
the URL is also provided by the backup software. The whoever creates this resource, the URL.
Yeah, it's either or. Like if it is in service, in cluster service, it would be the service name. If it is some external endpoint, it would just be a URL. So this approach is very is exactly the same of what the admission webhook is doing. You tell the API server where to find the webhook, and then you just call it, and then it will trust it only if the TLS endpoint on the other side is signed by the cert that it trusts. Because I think fundamentally, sorry, just thinking through this as we speak. I feel like that will keep our control, our CBT controller very simple. It's just a simple sidecar, and it will call an endpoint provided by the user, and you will only trust the endpoint if the endpoint is signed by a cert that it trusts.
Yeah, I don't know. I don't know. This one is like I don't know. It doesn't hit. Gut feeling is like, I wouldn't want to do that. I mean, things like what happens if it can't contact the endpoint?
It flips the client server role too much. I mean, you can't just be a client, you have to be a server also.
Yeah, it's almost like X Windows.
yeah, and it takes away, flow control and other things which the software may want. I would not use this pattern. Yeah.
The Kubernetes API server does that. It calls into admission webhook.
But that's providing a service back to Kubernetes. Right, the admission webhook is a service to Kubernetes. This is not really a service to Kubernetes. This is how we get access to some data from Kubernetes. So, you can look at the way the gRPC mechanism works. The CSI driver calls a gRPC. But gRPC is a server that's providing services to Kubernetes. The same way with the admission webhook, right? That's providing services to Kubernetes saying, yes, I'm going to tell you when you can admit something.
To have a listener in your effectively your client to receive this forces you to deploy your backup software in such a way that things can hit it on the network, which you might not want to do.
Yeah, like right now, when I was working on Valero, one of the things I like to do with Valero is I just run the whole thing on my desktop. And because it's talking to the API server, it doesn't matter where it runs. And I didn't have to have an IP address that the API server, that the Kubernetes cluster could talk to.
It will be a service in front of the backup software, right? It won't be an IP address.
You know what I mean, though. I mean, it has to be accessible. So if I try to debug, for example, the CBT driver on my desktop, it's got to provide an endpoint that the Kubernetes cluster I'm working with can talk to.
Well, yeah, with the callback URL or with aggregated API server, the backup software is already it needs to know how to talk over HTTP, right?
No, it doesn't have to provide, it can talk to HTTP. It doesn't have to provide an HTTP service back.
Yeah, in principle today, you can run backup software outside the cluster, far, far away from the cluster. And as long as it can reach the cluster, it can do its job. This would force the cluster to be able to find the backup software on the network, wherever it is, which is a significant restriction.
Yeah, I mean, it's not in principle. I mean, I've done it, right? That's how we commonly worked on Valero. And I think some other folks are doing that too. I think, to some extent, Power Protect runs outside the cluster.
So, yeah, undeniably, it will mean more sophistication on the backup software side. But I think it feels like it will still boils down to Kubernetes networking though, right? Like in terms of whether it is in cluster or out of cluster, I feel like it's just Kubernetes.
No, it's a question of like crossing NAT boundaries and crossing firewall boundaries. Like today, you can on your laptop on an airplane connect to a Kubernetes cluster that's running in California, and everything's fine, right? Because all the firewalls and all the NAT lets your packets travel from your laptop to the cluster. But like the likelihood of that cluster being able to ping your listener on the airplane is nil, right? It'll never get through all the firewalls and all the NAT that happens in that scenario. So it's too much of an inversion of the client server model, I think. Especially if there's no significant benefit that it offers over the other proposals. And I haven't heard a reason why it's head and shoulders better than the other ways of doing this.
I think like
I don't think it solves the scaling problem. People brought up the question of flow control issues, which are real.
We still got to return things like error status. Like, for example, if the URL that's provided doesn't work, you've got to put the status, that, hey, I couldn't contact this. That has to wind up somewhere.
There's also another advantage to having the site with the controller be able to return a URL in the status, in that the controller then has the ability to implement itself in different ways. It could, for example, kick off a separate process just to handle each volume independently, right? Or each session independently. So, because it has to look after its own memory and scale. So there are a lot of advantages to just staying with the traditional model over this.
And this may also open up some other weirdnesses, like, I don't know, there's always some weird security thing when you do something different, but like, can you leak data out via this mechanism? Can you, saturate outbound connections? Can you do something bad with it?
Yeah, well, I think I don't think you can leak it because we're not exposing anything on the controller side. But I think okay, it sounds like the main drawback is that switch off the server client flow, which is fair and good point. Okay.
I think it also isn't idempotent. So with the other, even with the URL, the inbound URL approach, I write this, I get back the URL, I can hit the URL multiple times. So if I have an error on my side, I can just hit the URL again.
Yeah, it basically shifts the complexity to the backup software side, right? The backup software.
Well, what do you expect to happen though? So for example, it starts streaming data to me. It streams CBT records to me. Good. Halfway through, some stupid thing happens. Somebody restarts the backup software, we hit a bug, whatever it is, the backup software crashes. Now, how do you restart that stream of data coming across? So like this volume snapshot delta would have to get written like once per per request of sending data, right?
Mm-hmm. Well, yeah. Mm-hmm. We'll probably have the same thing on the controller side, which yeah, it's feels like it's something that we have to address.
You need to be able to restart an aborted transfer of the deltas. So
right.
It's very easy to do that with a URL and a client that just calls it, and then if anything blows up, you just start over.
Okay.
Very easy.
Yeah, and here's going back to sounds like our server needs to have more control over those kind of scenarios, which again is fair and good point.
And the client needs to be able to handle all of these inbound scenarios, which currently it didn't have to. I mean, you could see currently like a retry loop would be just, okay, here, is there a volume snapshot delta record? Yes. Okay, then I'll pull the URL from it or the records, and I'll pull those out, and I can restart on that.
Mhm.
Versus, it's like, okay, I want it. It becomes this becomes very imperative, not declarative, right? Because it's basically a one shot.
Yeah, I mean, with the whole sub-resource approach. Okay, so I don't want to go down there. I don't want to go down the path. But okay, so cool. Thanks for the feedback on this. It looks like this does not work, but hey, at least we talk about it, we explore it. That's great. I can add this to the alternative section in the cap. So with 5 minutes left, I want to see I want to just confirm the next step forward with this cap. So it sounds
Sorry to interrupt. I think we had also talked about one more approach where we wanted to treat the change log as a resource, and then when client does list on change logs, our aggregated API server will do on-demand CSI snapshot, CSI call, and then returns the response as part of list API response.
Right. We were discussing that. I think on our side, we should probably sit down and go through how that might work and really nail down the flow there, and then we can look at pros and cons of that.
Okay. I thought we haven't discussed that. Yeah, that's fine.
Cool. Thanks, Prasad. So right now, at least I'm hearing two streams of thoughts here, which I think is not hard to reconcile. There was still that lingering question around do we need an aggregated API server? And it sounds like it's worth spending more time investigating into it.
Right. So the one action item would be, maybe Dave can help with this, just to draft a high-level user workflow with aggregated API server, and then compare that with the proposed approach or the existing approach. That's one action item.
Okay.
This meeting.
Okay, and then that would, yeah, that sounds good. And then
yes, so that would be something that we could go through in the next meeting.
And that would lead us back. Okay, so that will help us to decide whether we truly need an aggregated API server. And so far, it sounds like the only benefits of an aggregated API server is that it allowed us to call the sub-resource in somewhat an imperative manner.
Well, and you get all the ergonomics with the RBAC and the just the same API endpoints that you would get, so you only have to talk to one thing instead of having to talk to a whole other API server with its own certificates and its own authentication. I mean, even if it piggybacks on the authentication, it's going to have its own certificates, and it's going to have to call out to do delegated authentication. Like aggregated API does have the benefit that it just wraps all that up.
It still need it still need an API service resource in front of it, and we still have to provide all the cert and stuff, unfortunately.
But I mean, from a client's perspective, it looks a lot simpler. For us, it's still a lot of hassle to write the code.
Mm-hmm.
But for the guy who's writing the backup software, it just looks like he's interacting with the Kubernetes resource, like any other Kubernetes resource, and you can use all the same clients and all the same everything.
So it doesn't use etcd. I mean, that to me is the single biggest use of an aggregate API.
The other proposal though also does not use etcd. To be clear, if we just have an external URL,
it leaves the request because you have a CRD that, yeah, I guess it leaves the request for the difference. But yeah, all right, yeah.
Yeah, so both approaches allow us to avoid persisting the results on any storage anywhere. You can stream them, but it's a question of what the end user experience is. And it does sound like aggregated API is a better end user experience, although possibly more work to implement it than the other approach, which is the CRD with the URL.
The other okay. So what are the are there any specific thing that we are criteria that we are looking for at this point, or do we just want to get a sense of like how aggregated API server will look like? Because like
so with every alternative, we need to look at the details how that works, right? Then we compare with the existing approach, right? I think it's not clear today. I think because there are people talking about different things, it was not very clear. That's why you know, if you look at this section, this is very short, right? So we like to have that you know, talk about how that would work. It's a high level user workflow. So like some steps, how that would work.
okay.
So this is this is not very clear. Yes, this.
But I think we have enough evidence that it's worth going to that next level, right?
But we did not really get to the details on how that works yet. I think just there are people talking the different directions.
Right. No, but
Right,
Ivan's
right.
asking like, what are we doing? So I think the goal is to get pros and cons for the different cases. There's always a compromise. There's always something that doesn't work quite right. So we want to at least be able to put it all on the table and say, here's the one that we picked and here's why. Right?
I would say like so some of the options we can rule out immediately, like you know having them callback mechanism. I think we can rule out anything that's going to persist data on etcd. I think we can rule out. But like once you eliminate the things that are definite no's, there's still some different options. And at that point, I think it's going to come down to, you know, user experience and how much implementation work it's going to be and how hard it's going to be to maintain and questions of scaling. Those kinds of things will end up driving which one we do.
Yeah.
Probably.
And future stuff. You know, one advantage actually to the URL approach is it opens the door for a data path.
Hey, sorry, I think we are at the top of the hour. We have another meeting coming up. So yeah, so let's you know, meet again, talk about this again in the next meeting. And Ivan, we can chat on the Slack.
Yep. Okay, that sounds good.
Okay.
Okay, cool.
Thank you.
Thanks, everybody.
All right. Bye.
Bye.
The